Hey everyone, welcome back to the channel. Today we're continuing our DP-600 exam preparation course and we're up to video 8. We're making a very good progress here on the course plan. Today we're going to be looking at optimizing performance, and specifically we're going to be covering these bullet points in the DP-600 study guide. So we're going to be looking at mainly identifying and resolving performance issues, right? So when you're loading data or when you're querying data or transforming data. And specifically, we're going to be looking within the Dataflow, the notebook, so the Spark engine, and also SQL queries as well. Then we're going to look at delta tables in a bit more detail, how we can identify and resolve issues within our delta tables. As you know, Fabric is built on top of the delta file formats. So that's a really important topic to understand. And as part of that, we're going to be looking at file partitioning as well. So what that is, what that looks like, why you might want to implement file partitioning in your lakehouse. So as ever, at the end of the video, we'll be testing some of your knowledge from the topics that we cover in this lesson. And as ever, I've got some quite detailed notes that you can use to enhance your revision available in our school community. And I'll leave a link to that in the description box below. So most of this video, I'm going to be diving into Fabric and going through performance optimization in a number of different places in Fabric. But I just wanted to start by framing what we mean really by performance optimization in Fabric. Now, as you know, Fabric is a very diverse tool. So when we talk about performance, really we need to get a bit more specific about, well, what are we talking about? It could be data flow performance, could be a SQL script in your data warehouse, or we could talk about the delta files and optimizing how they get written and read in our OneLake, in our lakehouses as well. And I would make the distinction here between identifying performance issues and then resolving them. It's kind of like a two-step process. First, we need to know how to identify performance issues in each of these tools. And then we need to think about how we can possibly resolve these issues after we identify them. And you'll notice for each of the Fabric items, how we identify performance issues is going to be a little bit different, right? So for the data flow, we're going to be looking at the refresh history and the monitoring hub and the capacity metrics app. And you notice that some of these actually repeat. So the monitoring hub and the capacity metrics app is kind of like a generic place where you can do lots of performance monitoring across Fabric. In the data warehouse, we have Query Insights and DMVs, dynamic management views. With the Spark engine, we have the Spark history server, and we also have access to quite detailed monitoring in the monitoring hub as well. And when we're identifying performance issues in Delta files, there's a number of places you can do that. One of them that we're going to be looking at is describe. Then when it comes to resolving some of these issues, well, that's where it gets a bit more difficult to define, right? Because it's normally going to involve some element of refactoring. So using different operations in your data flow, for example, or refactoring your SQL code or refactoring your Spark jobs as well. Now in the data flow, we have some specific performance optimization features that is worth going through. So we'll be talking a little bit about staging and fast copy as well. Then when it comes to delta file optimization, we're going to go into a bit more detail about V-order optimization, file partitioning, and also the vacuum and optimize, which are two delta table functions that we can implement to improve performance with delta files. So that's a bit of an overview of what we're going to be discussing in this lesson. Now let's dive into Fabric, and we're going to begin by looking at some of the generic tools like the monitoring hub and the capacity metrics app before diving into the data flow, the data warehouse, and the Spark notebook in more detail. So let's begin. Okay, so just before we jump into Fabric for this tutorial, I'm just going to start in the school community here and talk through some of the notes that we have for optimizing performance. So here is video 8, optimizing performance. We've got this framing performance optimization chart that we spoke about previously. But to get us started, I want to speak generally about performance monitoring. There's a few tools that are quite general. They apply across different workloads that are useful to know for the exam and also in Fabric generally. So we're going to be talking about the monitoring hub and the capacity metrics app. And these are two tools that can be used to monitor performance for a wide variety of operations in Fabric. So the monitoring hub is the first one. So let's start by looking at the monitoring hub. And if I just flick over to Power BI here, obviously to access the monitoring hub, you've probably seen it here. It's in the left-hand toolbar here. You've got this big button for monitoring hub. And within here, we can basically have a look at the runs of a lot of different item types, right? So you can see semantic model refreshes, notebooks. So this is going to be a Spark session. And for each item type, we have different logging that gets exposed in this monitoring hub. Now the notebook we're going to have a look at in a bit more detail because that's exposing Spark log information. You can also see like Dataflow Gen 2. You can have a look at whether those runs have succeeded or not. Table loading information in a lakehouse, for example. And we can obviously click through into specific items that we care about and we get more information, right? So this is showing a table load into the bronze lakehouse, and it's showing you the different jobs because this is a lakehouse, these Spark jobs, right? So it's also going to tell us in the monitoring hub whether runs have been successful or failed. So this particular Dataflow run, we can see that it actually failed, right? So on the 1st of May at 12:46, I tried to refresh this Dataflow and actually failed. So you can click on view detail and you can get a few more details about what happened here. You can't really diagnose what went wrong with that particular data flow. To actually get the details of the data flow, you have to actually go into the data flow itself, which is this one here. And then we can click on these three dots here, click on the refresh history. So for data flows, if you want to actually debug what went wrong, this is obviously pretty poor data flow this, but you can click on the individual runs and get more detailed information about what's going wrong here. So here we can see, oh, it's actually this activity here that's failed. We can click on that and then get more information about why specifically that column or that data set can't be refreshed. So the next general tool that we can use to monitor performance and resource consumption within our Fabric capacities is the Capacity Metrics app. And the Capacity Metrics app, and I'll leave a link, you can obviously get the install instructions here if you have never installed this before. This is a Power BI app that you install within your Fabric environment. You give it your capacity ID, and again, the capacity settings is where you'll find that capacity ID. And then it's going to bring you through to this kind of Capacity Metrics app. Now, the Capacity Metrics app is split into two sections. We have compute and storage. And this obviously lines up with how Fabric is built, right? You're built partly on storage, so the amount of storage you have in Fabric, plus the resources that you consume during compute. So if you've already installed the Capacity Metrics app, you can find it in the Power BI experience, go to apps, and then you should see it there, the Microsoft Fabric Capacity Metrics app. Now, as I mentioned, there's two tabs to this report. It's compute and storage. On the compute page, so starting at the top left, we can see the capacity unit spend for particular item types in Fabric. And we can also break it down by duration, different operations, and by user as well. We also get this time series of capacity usage over time as a percentage of the total capacity that you have available based on your SKU. So currently I'm on this trial capacity. So this is going to be an F64. And as you can see, I'm not really using barely any of this capacity. We've also got these other interesting graphs around throttling. So if you're using more than 100% of your capacity usage on that particular capacity, this is going to show you where you're throttling. And it's also going to show you rejections. So if you've got workloads that are being rejected on your capacity because you're, again, over 100% and it's currently rejecting workloads, then that's going to be exposed here. We've also got a graph on overages. So again, if your capacity is throttled, an overage is basically you repaying that capacity usage from your future spend, right? And for each of these, obviously I haven't actually been throttled or there's no overage on my actual capacity, but there is this explore button that you can drill through to specific events that you want to explore in more detail, if that is something that's happening on your capacity. Down below, you've got a table of all of the different items in your Fabric capacity and the capacity unit seconds that are being used by that specific resource. So this is a Synapse notebook, and we can see that that is the most resource intensive. It's used up the most of our capacity unit seconds. And it's also got this tooltip where you can look at specific activities and runs of that notebook to dig into a bit more detail there. On the storage tab, obviously this focuses on the amount of gigabytes of storage in this Fabric capacity. We can see how it's changing over time. We can look at the specific storage by date, and we can also look at the top 10 workspaces by billable storage. Once that's loaded, that's what that brings you there. Here we go. Okay, so next I just wanted to talk about data flows. And just to summarize what we looked at previously, well, if we want to monitor the performance of a data flow, well, at a high level, we can do that within the monitoring hub. But if you want a bit of a lower level data and to understand what's happening within a particular data flow, you're going to be wanting to look at the refresh history as I showed you previously for a particular data flow. Here you can inspect the error messages, you get a breakdown of the different sub-activities in that load for a data flow. So that's going to be really important for you to diagnose what's going wrong in a particular data flow. If it's not refreshing correctly, that's where you're going to go to have a look there. Now there's a couple of features that you need to be aware about in terms of optimizing the performance, specifically when we're talking about data flows, right? So the main one is staging. Now, staging is probably best described using this diagram here. So this diagram actually comes from this link here. It's the Spotlight blog on data flows, and it's got some top tips for improving the performance in your data flows. So I think to understand what's going on with staging, this diagram gives you a pretty good idea. So let's start by talking about when staging is disabled. So this bottom diagram here, right? So if staging is disabled, all of your transformation in a data flow is going to be done by the Dataflow engine. It's otherwise known as the mashup engine, right? And if you've got a really big data set or you're doing lots of transformation, that might not be the most efficient way of doing it. So a feature we have available to us to try and improve the speed of doing all these transformations within a data flow is staging. So at the top here, when staging is enabled, what it's going to do is it's going to read in the data from the data source, and then it's going to immediately write that data into a lakehouse staging table. Then it's going to use that lakehouse to perform the transformation, right? So leveraging the Spark engine rather than the mashup engine to do your transformation. Then it's going to read the data back into the mashup engine and write it into the destination, wherever that might be. So a few things to bear in mind here. If you've got a lot of data transformations or you've got very large amounts of data, staging is probably going to be a lot more efficient. Now, if you've got small data sets, it's probably going to be less efficient, right? Because you're going to have to write the data into a lakehouse, transform it into the lakehouse, and then write it. Then the mashup engine picks it up again and writes it to your output destination. So there's lots of kind of reading and writing here. So on small data sets, you probably want to disable staging or not enable staging. It's only really when the data set becomes large or you're doing lots of transformation on that data set, then we want to enable staging. That's what I've kind of summarized with this sentence here. There's a bit of an overhead when you're performing staging, and so it doesn't work in all cases, only really when your data set is large or you're doing lots of transformations, or both. Now, another feature that they recently announced, and therefore might not actually be in the exam yet, but it's good to kind of understand and know that it exists, is fast copy. And the way that I think fast copy works is that under the hood, it uses the same technology as the data pipeline copy data activity, rather than the data flow technology, basically. As I mentioned, it's still a preview feature and it's relatively recent, so it might not actually be in the exam yet. But if you're using data flows in the real world and you're struggling with performance, it's worthwhile enabling fast copy. Just to give it a go, see how it impacts the performance in your data flows. Okay, so next up, we're going to move on from data flows, and now we're going to focus on SQL. So we have the SQL engine within the data warehouse and also the SQL endpoint of the lakehouse as well. And we're going to have a look at how we can diagnose and then optimize the performance of SQL scripts. And as I mentioned before, the Capacity Metrics app can give you a good kind of high-level overview of the resource consumption of specific operations that you're doing within your data warehouse. But we have a lot more functionality within the data warehouse to actually explore and identifying things like long-running queries, frequently used queries. Next, we're going to talk about dynamic management views, or DMVs. And if you take a look in the data warehouse under the sys schema, there's obviously a lot of different views in there that we can use for database management in general. And there's three main ones really for understanding the live SQL query lifecycle. Okay, so things that are currently going on in your data warehouse that you need to be aware of and getting some insights about what's happening there. And these are exec connections, exec sessions, and exec requests. And these are related in this way here. So we've got a bit of a data model here. So whenever you start a query execution in the data warehouse, it's going to start up a session. The session is going to have a one-to-one relationship normally with the connections, right? So it's going to create a connection between your data warehouse and the underlying SQL engine. So that's what a connection is going to show you. And then you're going to have many requests normally for each of these connections, right? So using these three commands, these three DMVs, we can begin to build a bit of a picture about who and how your data warehouse is being queried. And these DMVs are going to help you answer questions like, who is the user running the current session? When was the session started by the user? What's the ID of the connection to the data warehouse that is running a particular request? How many queries are actually currently active? And which queries are long running? So you begin to build a bit of a picture about how your data warehouse is being queried, who's querying it, what they're doing, and the performance of those queries. Now the DMV is quite a low level view, right? We can do lots of information here. We can merge these tables in different ways to get more and more information. So alongside the DMVs, Microsoft also expose Query Insights. So Query Insights is in a different schema. So if we have a look here at this particular example of a data warehouse, we've got the sys, which is our DMVs, where it contains our DMVs, as well as other database management system generated views. We've also got Query Insights. So in here, we've got these 4 views that give us basically more user-friendly abstractions over the DMVs, right? So it's going to expose things like frequently run queries, long-running queries, and you don't have to actually perform those joins of the underlying DMVs to get this information. It just exposes them right here. And so we're just going to focus on 3 of these Query Insights views. So exec requests history is going to return information about each completed SQL request on that particular data warehouse. Frequently run queries is obviously going to give you information about the most frequently run queries, and long running queries is basically going to return you information about queries by execution time. So this long running queries is going to be really useful to, as the name suggests, identify queries that are running for a long time, and it might be causing performance issues in your data warehouse. Now, one thing to note here is that if you're coming from a SQL Server background, when we're talking about performance optimization, a really important tool there is the query plan, right? So currently, I don't think it's possible to expose the query plan for a particular SQL query, but I do think they are planning to support that in the future. Next up, I want to talk about identifying performance issues with the Spark engine. And you'll notice that we're back in the monitoring hub. And I just want to look at one of the item details here for this specific notebook. So I've been running this notebook, it's called Delta Optimization. And when we click through on this item, we get a really detailed analysis of the different jobs that have been run in this notebook. We can see that all of these have succeeded. You can see the duration of a particular job, the data that's been read and written for that particular job. So this is a really good place to go if you want to understand what's actually happening when you click run in a Spark notebook, what's happening under the hood, and the success or failure of each of the individual Spark jobs. Now within the monitoring hub, we've also got this link through to the Spark history server. And as you can see from the UI here, we've actually switched from a Fabric tool to a generic Spark tool, right? So here you're going to get a lot more detailed information about specific Spark jobs that you're running. You can look at graph. So if you do want a bit of a query plan, look at the different stages in execution of a particular Spark job. You can have a look at that here. So if you're looking for really fine-grained control and analysis of what's going on your Spark engine, you're going to come to the Spark history server. Now to actually interpret and understand what's going on here would be a whole series in itself. And I don't think you need to know the nitty-gritty details of actually what's going on in the Spark history server for the DP-600 exam. Just understand, what's possible in the Spark history server. What does it log? What can you monitor there? I think that's good enough for the DP-600 exam. So finally in this tutorial, I just want to focus on Delta table optimization. Now, as you probably know, Fabric is built on top of Delta tables. So this is a really important topic to understand. And the Delta file format is great, but it can lead to poor performance and bloated storage sizes if we're not managing those Delta files correctly. Now, this is a topic that can run very deep, like a lot of the topics that I mentioned today. We're just going to go through some of the basics of what you need to know for the exam. And to do that, we're going to be going through a Spark notebook. So this is the Spark notebook that we're going to talk through. Now I'm going to start by just exploring the problem in a little bit of detail. And I think a really good way of understanding what the problem or a problem that can arise with Delta files is this visual here. And this visual comes from this blog post here by Sally Dubber, and it's around efficient data partitioning with Microsoft Fabric, best practices and implementation guide. And I've left a link to that in this notebook. The notebook is obviously available in the community here as well. And I've also left a link to it here, efficient data partitioning here as well. So if you have one big file that's 10 gigabytes, one Parquet file, then the Spark engine is going to struggle to process that, right? Because as you know, Spark is a distributed processing engine, which means it works best when it splits your file, your Parquet files, into smaller chunks and then processes these chunks in parallel. But to make that possible, we need to partition our data. And partitioning is basically the process of converting one really big or several really big files into more manageable chunks so that our data can be transformed in parallel, basically, by the Spark engine. So in this notebook, we're going to start by looking at file partitioning and then look at some other methods for optimizing delta tables. In doing so, this can help improve the read and retrieval performance. So by doing so, there's no need to scan through millions and millions of rows in your really big Parquet file. If you've got a good partitioning system in place, it's going to speed up the read performance of your queries. And it's also going to improve your transformation performance, right? As we mentioned before, because partitions can be transformed in parallel. So file partitioning. I'm going to walk through a bit of a demo here, and I've used a demo file and it's available on this website here, but it's just a Parquet file. What I've done is I've just put it in the files location. It's this one here. It's called flights 1M Parquet. And before we get started, it's just bearing in mind the best practices on Delta Lake partitioning, right? And I've left a link here. This is on the Delta Lake website where they give some general best practices about managing Delta files, okay? And one of them is around choosing the right partition column. Now, most commonly it's done by date. So if you've got time series data, you've got some dates in your data set, then it's common to use your date for partitioning. But there's two kind of rules of thumb to bear in mind when we're talking about partitioning and deciding what columns you want to partition on. So in general, we don't want to choose our partitioning column to be something of really high cardinality. So say, for example, you have a column of user ID. Well, that's going to be really high cardinality, right? Every row is basically going to be unique. So if you've got a million rows, that's going to be a really bad partitioning strategy, right? Because you're going to get a million different partitions and they're all going to be really small. And as a general rule of thumb, the amount of data that should be in each partition should be around 1 gigabyte. That's kind of like the good balance of what you should be aiming for with each partition. So let's take a look at file partitioning and how to actually implement it in Fabric in a Spark notebook. So I'm going to begin by just reading in that Parquet file, our flights 1M Parquet file. I'm just reading it into a data frame. I'm just displaying it here. And you notice we've got this date column here that's going to be useful for our partitioning strategy. We're going to be partitioning on date. And it's got some other items here that we don't really care about for this tutorial. So before we do some partitioning and we write this file into our lakehouse using partitions, we're going to do a bit of preparation. And specifically, we're going to add some columns into our data frame. We're going to use df with columns to add more than one column at a time. And we're going to pass in this dictionary object here. And each part of that dictionary, each key is going to be the new column name. And the value is going to be how we're actually computing that value. So here, I'm just reading in some PySpark SQL functions to extract the year, the month, and the day of month of that date field, right, that we looked at previously. So if we just run that, and if we just display the results here. Okay, so now we've got this transformed data frame object, right? And so you can see here that it's added in this year, month, and day column. And we can use these in our partitioning strategy now. So you can see here from our code cell that we've actually written 3 different write modes here. So the first one is going to write without partitions. So this is just the normal saving of the table into a lakehouse table from our Parquet file. We're going to put it in tables and we're going to call the table flights not partitioned. The second one we're going to do is we're going to call .partition by, and we're going to partition by the year and the month. And we're going to save this one into another table called flights partitioned. And then as a third example, we're going to write with some more partitions. So we're going to be partitioning our data into smaller partitions here. And again, we're calling partition by, but this time we're passing in the year, the month, and the day. So these are going to be more fine-grained. I'm going to save that into a table called flights partitioned daily. Let's just run those. Okay, so now our cell has been executed. All of our Spark jobs have concluded. Let's just have a look at this. So yeah, now you can see in our lakehouse tables, we've got flights not partitioned, flights partitioned, and flights partitioned daily. So we've got 3 different tables here, all with different partitioning strategies. So let's inspect those and see what's going on. Okay, so I've got 3 different cells here, and you'll notice we're using the SQL. So we're using Spark SQL here, and we're calling describe detail on that particular table. It's going to inspect this table. It's going to describe what's going on there. And some of the results give us a bit of a picture as to how this table has been written into OneLake. So if we inspect the results here, and this is our flights partitioned, we can see that the partition columns here are year and month, which makes sense because this is the year and month one in flights partitioned. And we can see the number of files that it's created. So the number of Parquet files we've got here is 2. Next, if we compare that to what we get when we look at flights not partitioned, we can see that we've got 0 partition columns and we've got 1 file. So everything's just been written into 1 file in that instance here. And for the daily one, again, if we inspect what's going on here, we can see that we've got year, month, and day partition columns. And here we've got 59 files. So here it's been partitioned. We've broken up that data into 59 smaller chunks of data. Now that might be too fine-grained, because if we scroll back up to the top here, one thing that I did mention is that it's a bit of a balancing act, this. Because if your files are too big, the Spark engine's going to have performance issues. But there's also the small file problem. If your file sizes are under that gigabyte, then that's also going to cause a lot of issues, because it's going to have to work harder. You're going to have to go through the operation 59 times rather than 2. So again, it's a bit of a balancing act, trying to get a good partitioning strategy for your Delta tables. But for the purposes of the exam, I think it's worthwhile understanding the syntax for creating partitions like so, and then analyzing different partitions using this describe method, Spark SQL method. Okay, so next I just want to talk about V-order optimization. Now, V-ordering is a Microsoft proprietary algorithm, and it basically changes the structure of your Parquet file. And what I've put here is kind of providing a bit of special sauce. So it does some special sorting, compaction, compression of that Parquet files, right? Ultimately to improve the read performance of these Parquet files across all of the different engines in Fabric. Now, whilst the actual algorithm is proprietary, it's only used by Microsoft, the output of the Parquet file is fully kind of open source. It aligns to the traditional Parquet standards, so you can actually read V-ordered Parquet files wherever you can read normal Parquet files. That's not a problem at all. Now, by default, V-ordering, so this algorithm that you use to write Parquet files, is enabled by default in the Fabric Spark runtime. And you can check that by running this spark conf get. So we're looking at the configuration, and you can see that here is actually returning true. Now it can actually be manually disabled if you want it to. So we can set the Spark configuration by passing in this specific property here, Spark SQL Parquet V-order enabled to false. And then we can re-enable it by doing the opposite, right? Putting it to true again. So for the exam, you might be asked about how do you know whether a particular notebook or a particular Spark environment has V-order enabled? Well, that's this one. Well, how do you enable it or disable it in a Spark notebook as well? That could be a common question that you might get asked. Okay, just finally, I just wanted to mention a few more Delta table maintenance and optimization techniques. So there's a few that come from the actual Delta format itself. So we have this function called optimize, which is a Delta Lake method that performs bin compaction. It can basically improve the speed of your read queries. So if you've got multiple small files, it's basically going to coalesce, basically mean joining small files into larger files. Vacuum is another function that we can run, and it basically involves removing files that are no longer referenced by a Delta table. And then on the Spark side, there's two that you might at least want to be familiar with is coalesce. So as we mentioned, when we're talking about optimize is basically what that's doing under the hood is calling coalesce. And coalesce is a Spark method for basically reducing the amount of partitions in your Delta table. So if you've got 100 partitions for a particular file, you can coalesce that Delta table into 10 partitions. So coalesce is a pretty efficient way of grouping partitions into a smaller number of partitions, right? And I say it's quite efficient because it doesn't require a shuffle of the data. It's just grouping partitions together. It doesn't actually reorganize within particular partitions your data. Now, repartition is similar to coalesce, but it's actually less efficient because it involves breaking up your existing partitions and then creating new partitions. And because of this, you can create either more or less partitions. So it's basically just restructuring how your partitions are created. And it does involve some shuffling, it involves breaking up of your existing partitions and repartitioning them. Now you might be thinking, what's the difference between the Spark functions and the Delta Optimize? Well, the Delta Optimize has a few kind of things working under the hood that makes it more efficient. For number one, it's idempotent. So if you run it repeatedly, it's not going to re-optimize files that have already been optimized, whereas repartition is going to always repartition your files. Like you can keep on running this again and again, and it's never going to get more efficient. It's always going to repartition the files. So that's one difference between repartition and optimize. And you can also run optimize on specific partitions in your data set, whereas repartition, that's kind of all or nothing approach. You have to repartition your whole table in one go. So if you're looking for a bit more fine-grained optimization, you're going to be wanting using the Delta Optimize. Okay, so let's just round off the video here by testing some of your knowledge of the things and the topics that we've covered in this lesson. Question 1. A client you're working with wants to reduce the SKU of their Fabric capacity. from an F16 to an F8 to save some money. They want to find the most resource-intensive workloads and optimize them to use less capacity unit seconds. Where should they look to find this information? Is it A, the monitoring hub, B, capacity metrics app, C, query insights, D, Spark history server, or E, the OneLake hub? Pause the video here, have a little think, and I'll reveal the answer to you shortly. Okay, so the answer here is B, the capacity metrics app. We're talking about resource intensive workloads, and our capacity is where we're going to get those resources, and specifically it's going to tell you which workloads are the most resource intensive, i.e. the workloads that are going to use more of your capacity units seconds, right? So the answer is going to be your capacity metrics app. We can look at all of our Spark jobs, our data warehouse operations, and our data flows, and we can come to conclusions about which of these are good candidates for refactoring or optimization. Now, all of the others, they might be useful for understanding performance of specific workloads within Fabric, but the capacity metrics app is the only one here that converts that into capacity units, right? And that's the important part of the question to understand. Question 2. You notice one of your Dataflow Gen 2 runs failed to refresh last night. Where would you go to find out why a particular Dataflow might have failed a particular run? Is it A, the capacity metrics app, B, the monitoring hub, C, Power Query error hub, D, Dataflow refresh history, or E, the data pipeline run history? So the answer here is D. The Dataflow refresh history is where you're going to go to analyze error messages and debug particular runs of a data flow. Now, the Power Query error hub, that doesn't actually exist. I made that up. The data pipeline run history, but we're not talking about data pipeline here, so it's not going to be that. The monitoring hub will give you some information, so it will tell you whether a particular run has failed or succeeded, but it doesn't give you more detailed information about error messages and things like that. And the capacity metrics app is not going to tell you that answer either. So the answer here is D, Dataflow refresh history. Question 3. When talking about delta table optimization, which of the following operation removes old files no longer referenced by a delta table log? Is it A, V order optimization, B, Z ordering, C, vacuum, D, optimize, or E, bin compaction? So the correct answer here is C, vacuum. So as we mentioned previously, the vacuum command does exactly as it's mentioned there. It basically removes old files that no longer referenced by a delta table log. So the correct answer here is C. Question 4. Which of the following statements about V-order optimization is false? A. V-order optimization is enabled by default in the Fabric Spark runtime. B. V-order can be enabled during table creation using table properties. C. A table can be both V-ordered and Z-ordered. D. V-order improves the read performance for Parquet files. E. V-order speeds up the write time of a Parquet file. So the correct answer here is E. So the question asked which of the following statements is false. And so E is actually false. V-order does not speed up the write time. It actually increases the write time of a Parquet file. The benefit of V-ordering comes in the read performance, right? That's why we do it. It takes a bit longer to write these files, but it massively improves the read performance across any of the engines that you might want to use it in Fabric. All of the other options are true, so it is enabled by default. B, if it's not already enabled in your Spark environment, it can be enabled for specific tables during table creation using table properties. You can actually optimize both V-ordering and Z-ordering for a particular table or Parquet file within that table at the same time. And D is also true because we mentioned that V-ordering does improve the read performance for Parquet files. That's why we do it. Question 5. You want to analyze long-running queries in a Fabric data warehouse. What's the minimum workspace role you need to run the following query? Select start from Query Insights .longrunning queries. Is it A, admin, B, member, C, contributor, or D, viewer? So the answer here is C, contributor. To be able to run a Query Insights query, those auto-generated views that give us information about long-running queries in this example, you need to have a workspace role of contributor. Obviously, the question asked for the minimum workspace role. You can also run these queries with admin or member, but the minimum workspace role would be contributor. So if you have a viewer role, you can't run these queries in a data warehouse. Congratulations, you've completed the biggest section of the exam. We're well over halfway now. So in the next lesson, we're going to be starting the third section of the exam, which is all about building semantic models. Well done, and I'll see you in the next video.